Welcome to the DIY Honda Garage channel. The DTC P2118 signifies a throttle actuator current range performance problem in the Honda Civic models from 2016 to 2021. This error code indicates that the vehicle's powertrain control module, PCM, has detected that the current being provided to the throttle actuator is outside of expected thresholds. The throttle actuator is responsible for controlling the amount of air entering the engine, thereby affecting engine performance, efficiency, and responsiveness. When the DTC P2118 is logged, it also means that the vehicle may experience erratic engine behavior, reduced power, or stalling since the throttle actuator does not function properly. It's crucial to undertake a systematic approach to diagnose and resolve this issue, as improper handling can lead to further complications or even additional DTCs being logged in the system. The DTC P2118 pertains specifically to the throttle actuator, a critical component responsible for regulating engine air intake by adjusting the throttle plate position. Located in the intake manifold, the throttle body interfaces directly with the engine and the air intake system. The powertrain control module, PCM, plays a vital role in this system, as it interprets signals from various sensors and modulates the throttle actuator's operation accordingly. If the throttle actuator does not receive the correct current or exhibits performance issues, the PCM triggers DTC P2118. This code acts as an alert, prompting the technician to inspect the throttle actuator and associated wiring for faults. Keeping the throttle body clean and ensuring all connections are secure can directly impact performance in mitigating such failures. When diagnosing DTC P2118, several possible causes should be considered. First, wiring issues between the PCM and throttle actuator can lead to intermittent connectivity or malfunction, thus triggering the error code. Specifically, open circuits or shorted wires may disrupt the necessary current flow to the actuator. Secondly, problems with the throttle body connector can also play a significant role. Loose or corroded terminals may impede proper functioning. Lastly, the throttle actuator itself may be defective due to wear, damage, or manufacturing defects leading to inadequate performance. Each of these possibilities must be carefully investigated to confirm the actual cause of the DTC P2118. The symptoms associated with DTC P2118 can be quite notable. Drivers may experience erratic engine behavior, unexpected acceleration or deceleration, which can create safety concerns. Loss of power, especially during acceleration, is a common symptom. The engine may struggle to maintain speed or responsiveness, which can be frustrating and potentially dangerous in traffic. Additionally, stalling conditions may also occur, particularly at low speeds or when idling, making the vehicle unreliable. If these symptoms are evident, it is crucial to address the underlying issue, as it can greatly impact the overall driving experience and safety. The first step in troubleshooting DTC P2118 begins with establishing the vehicle's operational mode. You will first turn the ignition to the on position without starting the engine. Next, using a Honda Diagnostic System HDS scan tool, clear the existing DTC codes. This is essential as it resets the system and prepares it to gather fresh data upon completion of the next actions. Following this, you will slowly press the accelerator pedal all the way to the floor. This action allows the system to test if the throttle actuator functions correctly and will help in identifying whether the DTC reoccurs as a confirmed fault or remains absent. If DTC P2118 appears again after this procedure, it indicates the issue is persistent and requires further investigation. Step 2 of diagnosing DTC P2118 involves a detailed inspection of wiring. Start by turning the vehicle's ignition to the off, lock, position. Using the HDS, you will then proceed to jump the SCS line, which stands for the Service Check Connector line, and wait for more than 1 minute. This action is important for preparing the system for the next diagnostic procedures. After waiting, disconnect both the PCM connector E and the throttle body 6P connector. Now, check for continuity between the designated test points, specifically between the throttle body 6P connector number 3 and the PCM connector E number 76. This continuity check is essential to determine whether there are any breaks in the SG3 wire that could be responsible for the DTC being triggered. Continuing with the troubleshooting process in Step 3, you're now focusing on the shorted wire check between the MTR1 and MTR2 lines. Begin by ensuring the vehicle remains in the off lock mode with the PCM connector E and throttle body 6P connector both disconnected. Next, measure the continuity between test points 1 and 2, which correspond to throttle body 6P connector terminals number 1 and number 2. Assessing continuity here helps to determine if there is a short in the wiring trouble that could be going unnoticed. If continuity is observed, this indicates a fault wherein MTR1 wire is shorted to the MTR2 wire. Necessary repairs should then be executed accordingly to rectify this wiring issue. In Step 4 of the troubleshooting process, you will further evaluate the MTR1 and MTR2 lines for shorts, this time checking against a body ground. Again, ensure the vehicle is in the off lock mode with the PCM and throttle body connectors disconnected. Focus your attention on continuity between throttle body 6P connector terminals number 1 and number 2, and the vehicle's body ground. The purpose here is to see if a short exists between these lines, which can cause abnormal behavior in the throttle actuator. If continuity is confirmed, this indicates there is indeed a short within the circuit, prompting you to effect repairs on the involved wiring. If no continuity is found, this suggests that the MTR1 and MTR2 wires are not shorted, allowing you to progress to the next diagnostic steps. Step 5 involves conducting an internal circuit check of the throttle body, aimed at measuring resistance levels. You will need the vehicle in the off-lock state, with both the PCM and throttle body connectors disconnected. At this point, measure the resistance between throttle body 6P connector terminals number 1 and number 2, which are located on the throttle body side. The standard resistance should fall within the range of approximately 1.2 ohms to 1.0 kiloohms. If the measured resistance is within this specified range, it suggests that the throttle body is functioning appropriately, allowing you to move to the next diagnostic step. However, should the resistance be outside this range, it necessitates replacing the throttle body entirely, as it indicates internal faults that cannot be rectified. The 6th step in troubleshooting DTC P2118 requires checking for continuity related to ground shorts in the throttle body circuit. Maintain the vehicle in the off-lock position with both the PCM and throttle body 6P connectors disconnected. In this step, verify continuity between throttle body 6P connector terminals number 1 and number 2 at the throttle body side and a body ground. If continuity is present, this indicates a short to ground, necessitating the immediate replacement of the throttle body. A component exhibiting electrical shorts is usually deemed non-repairable. Should there be no continuity, this signifies the internal circuit of the throttle body is intact. From there, refer to authorized service procedures regarding the DTC or symptoms, or consider substituting a known good PCM to reevaluate the situation, leading into further testing for DTC resolution. Conducting a final repair verification after addressing DTC P2118 is crucial to ensure proper functionality has been restored. First, verify that all wiring repairs made throughout the troubleshooting process have been executed correctly. This includes ensuring that every connector is securely reconnected and free from any corrosion or damage. Once confirmed, utilize the HDS to clear the DTCs once again from the system, which will reset any fault indicators active in the PCM. After that, initiate a road test to validate the vehicle's performance under normal driving conditions. Observing that the throttle response works seamlessly and no DTCs reappear will affirm that the repair was successful and the vehicle is restored to its optimal functioning. Preventive maintenance for the throttle actuator and associated systems can greatly help in avoiding future occurrences of DTC P2118. A recommended practice is to schedule regular cleaning of the throttle body. Carbon buildup can affect the actuator's performance significantly over time. Additionally, routinely inspect all electrical connections for signs of corrosion, loosening, or damage that may lead to intermittent faults. Engage in periodic diagnostic scans of the vehicle, particularly if any performance issues arise. This proactive approach allows for early detection of problems before they escalate into more significant issues. Overall, diligent maintenance helps prolong the lifespan of the throttle actuator and enhances the reliability of the vehicle's performance. In conclusion, effectively addressing DTC P2118 involves thorough diagnostics that prioritize both component functionality and the integrity of wiring and connections. Errors in the throttle actuator system can stem from a variety of causes, such as faulty wiring, electrical shorts, or issues within the actuator itself. Recognizing the importance of each step in the troubleshooting process is fundamental to identifying and rectifying the underlying issues. Furthermore, ongoing maintenance practices can prevent the reoccurrence of similar problems and ensure the longevity of vehicle performance. By adhering to these diagnostic and maintenance guidelines, you can contribute significantly to the operational reliability of the Honda Civic models affected. Please like and subscribe to the channel. See you next time.